This video will cover subtopic 4.4 in the ecology unit, dealing with climate change. These are the following expectations that we will cover in this video, and a little bit of guidance as well. So that's provided by IB. So carbon dioxide and methane and water vapor should be included in discussions about climate change, which we will do for sure. So we'll start with greenhouse gases as our beginning point for discussing climate change. So when we're talking greenhouse gases, these are gases in the atmosphere that keep Earth's temperature relatively stable. Without these gases, heat would not be retained, and the temperatures on Earth would fluctuate wildly between very cold and very hot. Carbon dioxide and water have the largest global warming effect due to their abundance within the atmosphere and their ability to trap heat. Methane and nitrous oxide have less of an impact on global warming due to the fact that they have lower amounts in the atmosphere, but have greater global warming potential than carbon dioxide or water vapor. Carbon dioxide can be released by respiration and combustion into the atmosphere, and can be removed by photosynthesis and by dissolving within large bodies of water. This was content covered in the video for lesson 4.3. Water vapor will evaporate into the atmosphere from oceans and from plants through the process of transpiration, and will enter the atmosphere in that manner. Nitrogen gas and oxygen gas are the most abundant gases that we have in the atmosphere, but are not considered greenhouse gases since they do not absorb long-wave radiation and do not contribute to the warming of the Earth, maintaining those stable temperatures. So the way a greenhouse gas works is that it has to do with the abundance of the gas in the atmosphere. And the abundance of the gas has to do with the rate of release and the persistence of the gas. So how long that gas lasts in the atmosphere. So for example, water vapor enters the atmosphere very rapidly, but only remains there for a few days, where it is returned back to the lithosphere through precipitation. Whereas something like CO2 can persist for years, and CO2 is also very abundant, making up about 400 parts per million by volume of the atmosphere. The other effect, or the other impact of a greenhouse gas is the ability to absorb long-wave radiation, especially that infrared radiation that's released by the lithosphere. So CO2 and water are very good at doing that. But there are other gases that are a lot more potent. So for example, methane has 33 more times the effect of CO2, but is not very abundant. With these gases in the atmosphere, the way that they work and the way the greenhouse gas effect works is that there is shortwave radiation that is emitted by the sun at around 400 nanometers in length. As this radiation enters into the atmosphere, some of it gets reflected, some of it gets absorbed by the atmosphere, but that shortwave radiation that reaches the Earth's surface then gets absorbed and will ultimately be re-emitted at a much longer wavelength. Much of the solar radiation that gets absorbed is ultraviolet. About 75% of that solar radiation does reach the Earth's surface, where it does get absorbed and then gets re-emitted at a longer wavelength. So you have this shortwave radiation coming in, it gets absorbed by the Earth's surface. That Earth's surface then re-emits that energy as a longer wave radiation and gets re-emitted as a longer wavelength. The greenhouse gases that are in the atmosphere are actually able to absorb up to about 85% of that heat that is re-emitted, and that is heat that gets trapped. So that heat remains within our atmosphere. The other 15% or so gets lost to space. So that heat that retains, that is retained within the atmosphere is what helps maintain the stable temperatures that we have on Earth. So there is evidence that has been gathered to show that there's a correlation between atmospheric carbon dioxide concentrations and average global temperature. So generally speaking, as atmospheric CO2 levels have been measured since the 60s, it's shown a steady increase in those CO2 concentrations. Meanwhile, there has been a steady increase in the global average temperature. Previous to the 1960s, CO2 atmospheric readings are done through ice core readings, and those also correlate with increasing global average temperatures as well. So those ice core samples come from the Antarctic, where research teams go out there and they drill down into the ice and basically obtain a core of ice that is many meters long. And the deeper the ice that they get, the more the further back in time they're measuring these carbon dioxide levels. As they melt the ice very carefully, bubbles are released from the ice, and they can measure the amount of carbon dioxide that gets released. So analysis of the gas content of the bubbles gives both the concentration of carbon dioxide in the atmosphere as well as the air temperature from oxygen isotopes at the time the ice was formed. Now, just because there is a correlation, it does not necessarily prove causation, but we know that CO2 is a greenhouse gas based on its ability to trap heat. And as temperatures are measured, the further back that you measure temperatures and the further back that you measure these CO2 levels, there seems to be correlations where fluctuations in CO2 levels seem to go with fluctuations in temperature levels. So when CO2 levels increase, temperature levels globally increase as well. And when CO2 levels drop, temperatures globally seem to drop as well. So since about the 1800s, around the start of the Industrial Revolution, when combustion of fossil fuels really started to increase, there has been an increasing level of CO2 from direct measurements since about the 1950s, but from the ice core levels as well. There's those indirect measurements which show an increase in those CO2 levels. And since about the 1950s, when there's been a large increase in the usage of fossil fuels by humans, there is a very steady and very rapid increase in CO2 emissions, which seem to suggest that they are anthropogenic in nature, or human-caused CO2 emissions. So global average temperatures, they're not directly proportional to greenhouse gas concentrations. There are other factors that can have a role in global temperatures, such as sunspot activity, which can have an effect on global average temperatures. Greenhouse gas concentrations, though, will likely cause, as these increase, it will lead to higher global average temperatures. As there's more gases in the atmosphere, they will be able to trap more heat. This will most likely lead to more frequent and intense heat waves, and some areas becoming more prone to droughts. Some areas will become more prone to intense periods of rainfall and flooding, basically shifts in weather patterns that we have happening, as well as tropical storms will become more frequent and more powerful, which we are tending to see with the hurricanes that are forming in recent years. And with these changes in greenhouse gas, there are increases in greenhouse gas concentrations, and these changes in global average temperatures, this can also lead to changes in ocean currents, which can have effects on climates of varying countries. So the following map shows current patterns around the world. So with the Gulf Stream, so this is warm water that's picked up by the equator and actually travels all the way northwards towards Western Europe, particularly England and Ireland. This warm water helps moderate the temperatures in that region, keeping them a bit warmer than what they should be. If there are changes to how these currents move, so if that warm water stops going into that northwestern part of Europe, this could have an effect on the temperatures in that area, causing them to decrease. With increasing CO2 levels in the atmosphere, this can also cause a threat to coral reefs. So oceans do absorb about 25% of the CO2 emitted in the atmosphere, but as that CO2 gets absorbed, it can cause the pH of seawater to decrease, as shown by the graph provided. So all the squiggly dark blue lines show an increasing levels of CO2 concentration in the water, and then the light blue squiggles show that the pH of seawater has been decreasing. It's not a very dramatic decrease, but a decrease enough that it can start having effects on biological life. So ultimately that decrease in pH is a result of ocean acidification. So as discussed in the previous video, this is where CO2 can react with water to form carbonic acid, and ultimately various types of carbonate and bicarbonate ions, ultimately releasing hydrogen ions, decreasing the pH of that water. The decrease in the pH of that water can have effects on things like corals and plankton as well. So the following example shows an organism that makes its shell out of calcium carbonate in varying levels or in more acidic conditions. The integrity of the shell over time decreases. So the viability of the organism is affected by these increasing pH in the seawater. And lastly, despite the evidence that shows that increasing CO2 levels has an effect on global average temperatures, there are many claims that human activities are not causing climate change, that the CO2, the increase in CO2 levels is not due to human activities. And these are claims that have been made in the media, both in newspapers, television, or on the internet. The internet's probably the most famous medium in which climate change skepticism is propagated. So it is important to realize that not all sources are trustworthy, and it is important to know the motivation of those publishing the claims on either side of the debate and kind of what they're aiming to achieve. So that's it for this video. The next step is to complete the Google form. This can be found on the Google slideshow.